line. So again, TruTech Tools, Eric Kaiser is our guest tonight to talk about refrigerant recovery best practices. Here's a TruTech team. We're here to serve, really. That's what we're all about. Is a longer and longer time I spend with the company really just boils down to customer service. That's what we try to do, is take care of people with information, with products, with support. Part of the support is things like we're doing here with Eric tonight. And it's also working with the network of people and bringing people that we know out there in the great big world of HVAC and building performance, bringing them in front of our customers and giving them opportunities that are sometimes hard to come by. And through some of the podcasts we do, through the videos, through the webinars, things like that, we really try to bring it together. And some people said, hey, you make my job more interesting. And that's like the biggest flattery I could ever hear, is that we're helping people out. That's what we're really trying to do. And we get good positive feedback. Where we get negative feedback, we try to correct ourselves. One thing I want to tell you is this picture has all our team from last June, from June of 2019. This is our team in June 2020. We've grown. We've added a lot of people because of customers, like maybe perhaps that are listening out there. We've moving through a lot more product, a lot faster, trying to get it in and get it out and build the kits to take care of our customers. So we've really added to our team, and want to thank you, those customers out there who have provided for our growth. This is a picture of our warehouse. We've moved only 5 times since we were born as a company. This is our latest iteration. It's 4 times bigger than the last place we're in. We have close to 90 brands of products, thousands of items, thousands of SKUs. And this is just sort of one look probably at a quarter of our warehouse. And the warehouse team really keeps things in order, gets things in and out very fast, works with our systems to take care of customers. If you're not familiar, we cover beyond just the refrigeration, air conditioning products, things like blower doors, duct leakage testers, infrared cameras, particulate IAQ meters, leak detectors, combustion analyzers. There's a wealth of products that we do offer at TruTech Tools, generally centered around HVAC and home performance.
And we'll hope they're seeing it. Anyways, okay, so let's get going tonight. Everybody, my name is Eric Kaiser. That is my email on the screen right there. So if you need to get a hold of me, feel free to email me with anything. Did just have somebody say my volume is a little bit low, so let's turn the mic gain up just a little bit, and hopefully that'll help. Okay, so let's keep moving on. Oops, get on the right screen here. There we go. First, Bill and Eric Preston at TruTech, and Bill Jr., who set all this up. I want to say thank you for having me on tonight, and hopefully everybody else. TruTech does a lot for this industry. Yeah, they sell all of us tools, and some really cool tools at that, because who doesn't love cool tools? Mm-hmm. But they do a lot for the industry, things like this that support the industry and training. And if you ever get a chance to see Bill in training, go see him. So guys, thank you very much. And also I wanted to tell everybody, go ahead and stick around after the slide presentation. I think we're going to stick around a little while and answer questions. So if you have questions, then we'll stick around afterwards. I'll go ahead and switch over to the live camera. And I can answer questions and show you things if you have questions at that point, because I've got all the stuff here sitting in front of me to be able to actually answer and display if you have questions. So anyways, let's move on. Here's some of what we're going to be covering tonight. Okay, we're going to talk about some regulations. We're going to set some terminology. We're going to talk about filling our recovery tanks. Interspersed throughout all this is going to be really safety topics. Things like that. Then we're going to also touch on increasing flow of refrigerant, right, which is all about getting the job done quicker. We're going to talk about the types of portable recovery machines, because there's 2 basic types out there on the market today. Look at different connection methods, what they do, some of the differences in them. Talk about hose purging, how to get our hose purging done really safely and do a good job of purging our hoses out. controlling our tank temperature, which right now with outdoor temperatures the way they are across the country, we're looking at a lot of people are heating up their tanks while they're recovering.
Bill Jr., TruTech Tools. What's your email address?
So we need to, I think Bill's got his mic, Bill Jr.'s got his mic on there.
Okay.
Anyway, so we need to control our tank temperature and keep that low.
Yeah.
And we're going to touch on maintenance
No
of
problem.
recovery machines basically as we go throughout. So let's get going on this. So we're looking at standards and regulations that we have for the industry. They typically come from 3 places with regards to refrigerant recovery, and that is we get it from EPA 608. All right, and that really covers the refrigerant types that need to be recovered, what the level in the system is that we need to recover to, and our record keeping requirements that we as either technicians or as the employers and the customers need to keep as far as records. We have AHRI Guideline K. All right, now that covers filling and storage of non-flammable refrigerants into recovery tanks. And then finally, we have DOT regulations, which can be found in CFR Title 49. And that covers the type of tanks that we can put on our trucks and take down the road, and really how full and at what level those tanks can be filled to. So we're going to talk about all of those things tonight. Now, any of these regulations can be found readily online. If you want to go out and search for them, you know, you can go out there and read them all yourself. There's some pretty dry reading in there, I'll warn you right now, and it takes a lot to read through them, and really different sections affect different things. You got to go back and forth a lot. So have a lot of fun if you want to read them. There's some interesting reading in there. I've learned a lot by going out and reading some of that. So feel free. Now, let's start talking about terminology. When we talk about recovery, a lot of times we talk about liquid recovery versus vapor recovery. So what is that really, right? Well, what we're talking about here is the state of the refrigerant as it enters the recovery machine. So liquid coming into the machine versus vapor coming into the machine. Now we have other places we need to look at this as well, like going into the tank. What's the condition of the refrigerant, or the state of that refrigerant going into the tank? Is it in liquid state or is it in vapor state? Because that's important. One of the problems that we have is that density changes, of course, when you change things to vapor, right? So we'll talk about that. Now let's take a look at some densities. You see on the screen R22, and we're talking about this in pounds per cubic foot. So how many pounds of refrigerant can we fit in 1 cubic foot? Density changes with temperature. So for instance, there at 75 degrees, our cubic foot of R22 is going to weigh that 74.8 pounds, or roughly 75 pounds. However, same cubic foot of volume, we can't fit all that liquid refrigerant into it if we warm that up, because suddenly we can only fit 66.3 pounds of refrigerant into that cubic foot when we warm it up to 130 degrees Fahrenheit. These things are going to come into play here as we're talking about this. And what I want you to realize is that liquid expands as it warms up. That's very important when we're talking about tank filling. Very important. Now, one of the interesting things is you look at vapor. If we look on the right-hand side, R22, vapor actually gets more dense in refrigerant as it warms up. This kind of was backwards to me when I first started thinking about it, but that's what the charts say. So at 75, we're at 2.7 pounds per cubic foot. At 130, we can fit 6 pounds per cubic foot in there. Now, part of that is going to be because as it warms up, it becomes more pressurized. Now, 410A. Again, 410A runs similarly in the way it behaves, but we're talking about different weights. 66 versus 54.7 at liquid, or 3.9 versus 9.9 over there on the vapor side. Now, when you compare the two of those, they don't weigh the same in liquid, which is what we fill our recovery tanks with. We need to fill them to that 80% capacity liquid full. Okay? So, this is a very important concept here to understand. Now, let's look at another, set some more terms. Direct recovery versus push-pull recovery. That direct recovery right there, we're looking at having the, let's see if I can do this here. Now, can you guys see my mouse cursor on that screen? Whoops, let's back up. You guys should be able to see my mouse cursor on that screen, I believe.
Yep.
Okay, good. So direct recovery, we're taking it out of the unit, we're going through the recovery machine and then pushing it into the tank. So we're making a low pressure by transferring this over and forcing it out into the tank. Push-pull, kind of do it a little differently. Now, push-pull is used when you can access a lot of liquid in the system itself. So what we have with that is we hook up where we can access the liquid. We take the liquid into the tank, and we take vapor out of the tank with the recovery machine, and we force the vapor back into the system to pressurize the system and push the liquid directly into the tank. We're going to talk about that a little bit towards the end, and I'll show you why you want to use that on larger systems, because it takes a little bit more time at the end, because you can't pull all the vapor out when you're talking about utilizing this system. You can't get the vapor out of it as well. Okay, recovery machine types. So out there, we've got two basic types of recovery machines. All right. The one on the left is a reciprocating recovery machine. It's pretty standard in the industry, been around for a long time. This style works very much like a reciprocating compressor. You got a crankshaft in here, you got a connecting rod, there is a piston up here inside of the cylinder, and then we've got a head out here. Now, just like a reciprocating compressor, this entire compartment in here is full of refrigerant. You can see the line connecting it over here on the left-hand side. This is all low-pressure refrigerant. It's the same pressure as whatever is coming into the unit. So it's tied to what we would call the suction side, or the inlet side of the recovery machine. Now, up here on top, this is where we have our high-pressure refrigerant. All right. The one on the right is a little bit different system, and it's out there only by Appion right now because they have a patent on this design. The biggest difference in these two is where they keep the refrigerant. And in the Appion design, the refrigerant is only out here on top of the pistons and inside the cylinders underneath the heads. No refrigerant gets into the crankcase portion of this. Okay, so that's the biggest difference really between those two. Performance-wise, the one on the left has a little bit higher internal volume in the cylinder. All right, so it tends to do a better job of vapor recovery. It'll do faster because we can get more stroke on that piston. So we increase the, oops, hitting the button too soon here. We increase the internal volume so we can move more vapor. Whereas the Appion style over here on the right, it handles liquid, direct liquid very, very well. Because of this style where they're horizontally opposed and they push on each other, it allows this to put liquid in here, and this thing will pump direct liquid through it, whereas these do not like direct liquid. They need some vapor in there, otherwise you end up damaging things, much like you're going to have with a typical reciprocating compressor if you get liquid into them. So that's a little bit about the two differences on the type of compressors out there on the market today. Either one of them is going to do the job. They will both handle liquid. The one on the left tends to need to throttle the inlet though, and it actually reduces that inlet a little bit so that you get a flashing happening before the refrigerant hits the compressor. And then they use the condenser coil after that to recondense that liquid back up. Or recondense that vapor back into liquid after the refrigerant flows through the compressor. All right. Now, we've got a poll question here, and I forgot to ask Bill how to start the polls.
I think if you float to the bottom of the screen, it should pop up a menu and the polls are available.
Uh-huh. Yeah, it's not. There it is. Polling.
Yep.
First question. Okay, here we go. So, on the recovery tank, what do the letters stamped WC stand for on that refrigerant recovery tank? So let's see what you guys think out there. Still got them coming in here. You got 4 choices. How many do we have online right now?
172, not including Bill, you and me.
Okay.
It stands for will call, doesn't it, Eric? Will call.
Oh, will call. I didn't even think about that one. That's a good one. I like that.
Make note, please. Make note.
It might stand for will call. It might stand for will call. Let's see. Yeah, looks like we're slowing down a little bit on there.
I usually wrap it up around 60% or so.
Okay. Yeah, it looks like we got about 71% voted. So let's, we're going to go ahead and end that here. We got about a minute on it. Okay. So we're going to end that now. And let's see, we have 35% of people say it's water column. 50% of people say it's water capacity. One person said it was water closet, and 15% said with contents. 50% of you were correct. That stands for water capacity. Okay? So there we're going to go share the results so you can see what happened there. All right? Okay. Let's close that down. There we go. WC, water capacity. This is straight off of a recovery tank right here. Water capacity means that is how many pounds of water that tank will hold. So how many pounds of water that will hold. We need to know that in order to fill the recovery tank safely. Because our limit on the recovery tanks is we want to fill them to 80% by volume. So water capacity is an important piece of the calculation. Now, let's take a look at that calculation a little bit more in depth. One other thing I want to mention is the TW on there, and I didn't ask that in a poll. TW is Tare Weight. Now, Tare Weight is the weight of the tank itself without anything in it. It's just the material of the tank. Okay, so that's your Tare Weight. Now, water capacity. When I came into the industry, I was taught you take that water capacity, you multiply it by 0.8, that gets your 80%. We fill the tank, we go on, we're good with life. Great. Well, not quite exact. That's not quite accurate. So HRI Guideline K says that we fill it to 80% of the water capacity multiplied by the refrigerant density. And each refrigerant has its own densities, as we saw earlier. Those densities are not easy to find. And actually, the AHRI Guideline K uses specific gravity. But you have to know at what temperature. AHRI guideline K calls out 75 degrees, I believe. It's either 75 or 77 degrees, somewhere right in there. The challenge with that is that DOT says 130 degrees because they don't want that to go over 80% when it's sitting in our hot trucks. Now, if you're going to store it at over 130 degrees Fahrenheit, you need to go back to 60%. Okay, so let's take a look at how we figure that out. This was the sheet that was emailed out to everybody earlier today. Okay, so you should all be able to get this and see this. And what this is a density multiplier sheet. So it gives us our density, pounds per cubic feet, at 130 degrees Fahrenheit. They're all listed out over here if you really want to do the math. Or it's pretty easy. There's refrigerant multipliers on the right-hand side. So you pick out a common refrigerant, whatever the refrigerant is you're using. Now notice 422A, 422B, 422C, 422D, they are not all the same. Even though they all use the same molecules, they're arranged differently, so they have different densities. So we need to know the exact refrigerant. Now you can find these densities, these pounds per cubic foot density, by going to the refrigerant manufacturer and getting the it's not the specifications chart, but it tells you all of the characteristics of that refrigerant. It's engineering data. So you can find these densities in there, and you can make up these multipliers if you want to, or if you really want to, if you have a trouble, go ahead and email me, and I'll be able to research things and find stuff for people if we have to. So down on the bottom, this is how we use these numbers, right? Calculation for max refrigerant in the tank. We take that tank water capacity times the refrigerant multiplier up here times 0.8. That gives you your max allowable refrigerant in that tank. And again, all these are done at 130 degrees Fahrenheit so that they agree with DOT regulations. Okay. Now, if you want to know how much you can fill that, or how much that tank can weigh maximum, you take that max refrigerant tank weight plus the Tare weight gives you your maximum total weight. So there's a couple examples down here, right? We run through that tank with R22 in it. We can put a maximum of 41.1 pounds in this particular tank. Now, this is what's known as a 50-pound tank. That's a nominal value. It is not the amount of refrigerant that we can put in the tank. Okay. And if we add that tank weight, the refrigerant weight to the 24-pound Tare weight, the maximum that particular tank can weigh is 65 pounds. So this was a little bit different than the way I was first taught. And I run across a lot of people in the industry that were really have not been doing it right. And we'll say it can be a little dangerous. Okay. There are relief valves on these tanks that can go off. There are other things that can happen. Okay. So it's very important to know how full we're filling the tank. One of the other things is we need to know how much refrigerant we're putting in that tank as we're putting it in. Because it's real easy to overfill a tank if we don't know what's going into that tank while we're actually doing the work. So what's the worst thing that can happen, you say? We get a little extra in it. So what? Well, that's probably one of the worst things that can happen. Thankfully, when that happened, there was nobody around. It was at night. I did not get the whole story on this. I got the picture and part of the story. It was in a distributor. Somebody brought the tank back in. They left overnight. They came back, and that tank started out life on the other side of that wall. If you look at the way the drywall is broken and the studs are bent, that tank was on the other side of the wall. The side seam blew out on it. That was the weakest point in the tank. And it ended up pushing itself clear through the wall and ended up laying down somewhere around where it's standing right now. So they stood it up and took that picture. My best guess is looking at it and thinking about what happened is that somebody brought that tank in during the day, maybe during the morning or something like that. It was almost liquid full. And this is what happens when you get a liquid full tank, is that liquid starts to expand and the hydraulic pressure pushes out. That's why we want to leave that cushion of vapor on top, that 20% cushion, so that we don't overpressurize the tanks.
Hey,
My
Eric,
guess is, yes, sir.
we got a couple questions that are rolled in that I think are pertinent right now
Okay.
to ask you.
All right.
Bruce asks, how would one calculate a multiplier for a refrigerant not listed, assuming you can find the density from the manufacturer? What is the math?
What do you, oh, not listed on that
Your sheet.
chart?
Yeah.
I do not have the math in front of me, and it's not on the top of my head right now. I actually have a whole spreadsheet that does it for me.
All right.
I'm sorry, guys. I am not a math whiz. That's the last thing. You want a math guy, talk to Bill.
Okay. And Eric and I will talk about this. Maybe there's something that can come out of this. We could expand on that sheet a little bit, and maybe Bruce, throw your favorite refrigerant in there that you think is missing.
Yeah, absolutely.
There was another question from Shanga. Is the 0.8 a standard set number part of the formula, or does it ever change?
The 0.8 is your 80% fill. So you're figuring out what it would be to liquid fill the tank using the multiplier, because the multiplier is in relation to water, right? So if we back up there, you look down at the bottom, you see where it shows the density of water there at 130 degrees Fahrenheit.
Right.
Okay, so all these are in relation to water.
Right. And someone else, Frank, asks, what about blended refrigerants? Well, it's really, a legitimate blend that has an R number on it, has a density that's pretty specific. So it could be put with your spreadsheet. It could be put on that kind of chart.
Yeah. If it's a mixed refrigerant, where you're talking about multiple different kinds of refrigerant mixed together, aka you don't know what the heck you have, you're kind of on your own there. Unfortunately, I hate to say that, but I would just be really cautious. And maybe what I would do is I would take that that water capacity, maybe just do like a 0.6 multiplier just on the water capacity, or maybe even a half of the water capacity. I would put that in that tank and then send it in and have it destroyed. Because when you're talking about a mixed refrigerant, you just have no idea what that's going to do. There's really no clue, because things do weird stuff. Absolutely. So I see a comment there about most mixed recoveries are after a leak, so the blends will be altered. No, not when you're talking about a single blend that's in the unit. And what I'm guessing you're talking about there is fractionations. So fractionation has been in an operating system. Okay. Nobody has yet found fractionation in the field. Multiples of the actual refrigerants have been tested coming back where they've had leaks. The refrigerant manufacturers have pulled them back. And this comes from the manufacturers, from the big manufacturers that do this testing. And they make money selling refrigerant, and they say that fractionation in the field doesn't happen. They haven't been able to prove it yet. So to me, fractionation in the field is really not much of a thing. Mixed refrigerants happens when somebody grabs the wrong tank and puts the wrong refrigerant in it, or the system isn't, somebody did a conversion on the system and didn't mark it, and somebody puts the original refrigerant into it instead of the converted refrigerant. Okay. So that's where mixed refrigeration or mixed refrigerants comes from, is from people putting wrong refrigerants in there. Again, like I said, the big manufacturers, nobody's found fractionation to actually be an issue in the field. It was a thing that everybody was worried about when it first come out. But after it's been in the field, we've pretty much disproved that one now, thankfully.
It is theoretical.
Yeah, it is very theoretical. It can be done in a laboratory. It can happen in a tank, a tank that is sitting dead still with a very, very slow leak on the vapor side, right? But if it's in a system, because that refrigerant moves around in those systems and those different components actually move together in the system, they don't separate and leak separately. They actually end up leaking as a system because that refrigerant is mixed together. So it's kind of interesting to learn that, because I was a big concern about fractionation when I started and I first learned about it. And then after everybody came out and they said, nope, not a big deal. So, all right, we good, Bill?
I think so.
Okay.
Yeah.
All right, let's move on to maintenance and internal damage in machines. Okay. So this is that reciprocating machine again, that I tore apart. It was an old one that I bought off of a guy because I wanted to tear one down, right? So I got a hold of one, and it had some problems in it when I tore it apart. Now there's two cylinders on this. There's one of these cylinders on either end of a motor. So there's twin cylinders in this. And you can see here, one of the first things I noticed when I popped the head off, right? This is the head on top of that piston, right? There's a valve missing here. So this is the intake valve. It's missing. Well, I pulled the cylinder up, and lo and behold, there's part of the intake valve right there stuck in between the piston and the cup seal. So this is another difference between those two types of recovery machines. The reciprocating style is just going to use a single cup seal here, okay, around this. And that's one reason why they have this refrigerant back here in the crankcase. So this is one thing that can happen to recovery machines as they break down. Now, this is an Appion that I got given parts to. Friend of mine, co-worker, he kept having problems with his filter dryer, inline filter dryer, and then the screen plugged up and everything was plugging up. So what do you do when they plug up? You take them out, right? And then lo and behold, this happened. Apparently he had a bunch of junk in the system. So you can see all the damage from the top of that piston right there that happened. You can see damage in here in the head. This valve opening has been beat up. There's scarring inside on the piston wall. It was just time to go buy a new recovery machine because I decided to take, right, the protection out. So that's when you see that dryer in there, that dryer is there solely to protect that machine. It's there to keep the big particulates from getting into that machine. Okay. And the other piece that's in there is on the inlet screen, or the inlet fitting, there's going to be a screen built in there. And they're a really fine mesh screen, and they are designed to be there in case the dryer decides to come apart. And that way it protects that machine again. In case the dryer comes apart, there's a screen there. Both of those can get plugged up. I've seen them plug. I've seen the screens plug up bad enough, and of course the dryers plug up bad enough to start causing frosting at those points. So if you start seeing frosting at that point, you've got liquid refrigerant coming in, and it's enough of a restriction that it's causing a flashing effect right there. So it's reducing the temperature after that component, whatever it is, the dryer or the screen. And at that time, you really need to get it apart, clean it out. And you may want to get a bigger dryer. If you've got a really dirty system, get the biggest dryer you can find. I think in 1/4 inch, the biggest one is like an 08, I believe, that you can get. And you can always adapt if you have to get up to bigger ones, right? So this overall is a pretty typical configuration we see, right? Got a manifold here, a couple hoses going over to our lines, coming off here in the inlet, going to the outlet. Okay, sitting on a scale. always, whenever you're filling that tank, make sure it's on the scale. Because the challenge is that we don't know how much refrigerant is in a system. We can look at the nameplate on it, but how do you know who's been there before you? And I learned this lesson with a former coworker the hard way up on a rooftop unit one time. We're working on this rooftop unit, and I'm across the roof working on another unit. He's tearing this apart to replace a compressor that was bad. Later, we found out there was some other problems. But he did a quick calculation on his tank, looked at the nameplate, said, yep, got plenty of room in this tank. He actually set it on the scale, but he didn't watch the scale as it was filling. And I'm across the roof, and I hear this whoosh noise coming off of his unit, coming from the direction of his unit. And of course, I'm sure I looked like a little gopher or something popping up. What in the heck's going on? Because he shouldn't be releasing nitrogen yet. He wasn't going to be to that point. It hadn't been long enough. And I look over there, and the relief on his tank was venting, right? And there's a relief valve on these recovery tanks, and I'll show you where it's at here in a little bit. The relief on his tank was venting. He's on the other side of the unit, thankfully. So he didn't get hit by that relief valve. But it taught me a couple lessons here. One, aim the relief valve away from wherever I'm going to be working at, because if that thing does for some reason decide to go off, I don't want to be standing in front of it. Even if it's just vapor coming out of there, it's still really cold vapor. All right. The second is that we have to watch that scale, because what we figured out afterwards, we went back and did some research trying to figure out what happened. You know, did we have a bad tank? Did we have too much refrigerant? What? And we found that somebody that was there before us had actually double charged that unit trying to make it run because they didn't understand what was happening. So they just kept cranking refrigerant in there, and they managed to stuff double the amount of refrigerant that was supposed to be in it. And of course, his tank didn't have room for that. Had he been watching his scale, he would have had the weight figured out, how much he could put in that tank. He would have known, hey, I got a problem here. I got to stop this and go get another tank. All right. So thankfully, the only thing we had to do that day was fill out some paperwork. That's all we had to do. Fill out paperwork for the accidental release. Worst case scenario, he could have been really hurt. All right. So just be safe out there. This stuff, you get complacent with it, and it'll get you. It'll bite you sooner or later. I think a lot of us have felt that cold refrigerant just taking things off and on, and I'm not a big fan now of getting my fingers burnt by refrigerant. So on the left there, you'll see that screen. That's one of the inlet filter screens that goes in this, and you can see how tiny that is. I mean, that thing's, you know what, not even, just barely half an inch, not quite half an inch in diameter. Okay. And then on the right there, get your flare filter dryers is what I use, the double male flares. And we'll show you a couple things on how to hook that up here. We can show you some actual hoses and physical connections after we get on the video later. Okay. Here's our second poll question of the night. So let's get to polling here. We're going to go into number 2. And there you go, guys. Okay. So when moving fluid through hoses, what are the 2 things that can be done to increase flow volume? Okay, we're looking to increase flow volume. So we've got 4 options there for you to choose from. And we've got one that pulled way out in the lead on that.
You think it's a safe bet then? You're going to put your money on
it might be. It might very well be. These guys might be really sharp tonight. Might be doing really good. How are we doing on time here? Okay, well, we're moving along. I still got a little bit more to cover.
Okay.
We might go just a hair long. Okay, we're at 72%, so I'm gonna go ahead 73. Looks like they're slowing down. All right, I'm gonna go ahead and end it there. Okay, so increased pressure differential, and I cannot see, it won't show me the whole poll.
Oh, I can read them
Number
off.
2. Yeah, so which one won? We got 78%.
Increased pressure differential and or, oh shoot, it doesn't show you the rest of the poll.
I think that's the correct answer. I think that's the correct answer.
And or decrease resistance.
Yep, there you go. Increase pressure differential and or decrease resistance.
Yep.
That's what we want to do. And by increasing the pressure differential, what we're talking about is pushing more into the hose or the pipe or whatever it is, right? Or if the pipe isn't big enough, we may need to increase that pipe or increase that hose and get rid of some of the restrictions in there. Okay. So that topic's going to be covered here. Now, let's move on to the next one. This is just kind of a question here. I'm going to ask you to think about it for a second, and then I'm going to give you the answer. Is a recovery tank as good at rejecting heat as a condenser coil? The answer, no, it is not equal to. Recovery tank is designed to store refrigerant. Condenser coil is designed to reject heat, right? It's designed to transfer heat one direction or the other. So they are two different things. They have two different uses. So we need to understand that and realize that as we're doing this. And this is going to come up here as an important topic as we go along. Okay. Now, when we're moving refrigerant, sometimes we can't increase the pressure anymore. Sometimes we're kind of limited by what the machine will do. So one of the easiest things when we want to move more volume is to increase the hose size or remove the restrictions. Okay. So one of the biggest restrictions we can easily take out is valve cores. And this picture shows you the difference between a valve core that's open with a depressor, right, in this cutaway right here, versus a valve core that is closed. And there ain't a whole lot of difference in there. And that refrigerant has to sneak by this little cap on the end all the way around the outside and then move over here, and it slides up inside that stem or inside this housing right alongside the stem. That's the refrigerant path through there. Comes all the way up and then comes out on either side of the flat pieces where we grab it with our core tool. It's better than a 90%, I'm going to say better than a 95% reduction in area in there for flow. So cores, great for accessing something for measuring pressure, terrible for moving things through in an expedient manner. And in today's world, we kind of need to get things done faster a lot of the time so we can go home, maybe we can get on to another customer's job, whatever that may be. So this shows those
maybe
two
watch
cutaways
a webinar.
again.
Who knows, maybe.
Well, yeah, I mean, you can come on, watch a webinar and learn something else.
The heck, yeah.
Sure. Yeah, exactly. Well, I mean, we're running short of technicians, so we need to get our stuff done faster if we don't have enough people to do it. It's one way to kind of mitigate that technician shortage. If we can be more efficient, we can actually get things done quicker, then we don't need to have as many people coming into the trade. I don't think we're going to solve the whole situation that way, but it's one way we can do it. So again, without that core in here, there's your passageway. Okay. And we use core tools to remove these. Okay. So the core tool has a plunger that comes in, and we actually make our connection back here. When we pull that plunger out, we have a control valve, and then we have a side port on the side where we can hook hoses up to, or other things to take measurements. The side port is always connected into the system. Make the system connection over here. You can get them in different sizes for 5/16. Like for instance, this one has a 5/16 connection on the left side, and then a 1/4 inch on the side and a 1/4 inch on the back. So not only is it a core removal tool, but it's also an adapter, so you can use your standard 1/4 inch fittings on your tools. All right. So that's some examples of different core tools there. Now, some of the other places we can remove restrictions in the hoses and the fittings. This one really surprised me the first time I cut open a couple of hoses to see what they looked like on the fittings. So over here on the right, this is a 3/8 OD, right? This is a 1/4 inch OD fitting to go in 1/4 inch ID hose. This goes in 3/8 ID hose. And here's the ends of those two fittings. The 1/4 inch fitting actually necks down to about 1/8 of an inch in the middle of it. So it is pretty doggone restrictive. The 3/8 is just a little bit over a 1/4 inch inside diameter through that fitting. So much less restrictive. All right. And these are different size hoses. This is a 1/4 inch hose. These are all ID, 3/8 ID, 1/2 inch ID hoses. So you can take that 1/4 inch hose and actually drop it down in the middle of that 1/2 inch. So things move a lot faster. Now, typically for refrigerant recovery, we're going to use either 1/4 inch or 3/8. Some people will use 1/2. I haven't seen a ton of benefit to it as far as speed, but some people say it does. So if you're doing a lot of stuff, maybe if you're running a really, really long distance, 1/2 inch might be the choice. Okay. One of the other things we can do in hoses is take out our core depressors in there. Okay. That is a big restriction when you're looking at those two holes right there. Now, the idea here is that we're removing restrictions, and removing restrictions allows us to keep things liquid more. Remember, liquid has higher density, so if we can move things from the system into the tank and keep them liquid or mostly liquid the whole way through, and we're not flashing them off to 100% vapor, that means we get our refrigerant into the tank, we get the tank filled as liquid, and we don't have to reject any heat out of the vapor that goes into the tank, or very little, because that tank is a lousy condenser. It's a lousy heat transfer tool. So if we can fill that tank with liquid, we're better off. Here's a couple more. So here's how we apply these, right? First, we're going to put the core tools over here on our access port. That's where we're going to connect our hoses on the back side after we take the cores out. When I work on a system, these core tools, my first on, last off devices. I use them all the way from recovery. I use them through service because now I have 1/4 inch or 1/4 turn ball valves on here, so I can turn that system off and isolate it from the atmosphere whenever I want to, the whole time I'm working with it. The only time I'm going to take those off when I'm working with it is if I'm brazing nearby, because I don't want to get the temperature into them and risk doing damage to that. Other than that, they're on there the entire time I'm working on that system because it allows me to have control over it. All right. One of the next things we can do is the discharge side of our recovery machine. We can come over here and put a larger hose, typically a 3/8. Recommended to keep that under 4 foot or right at 4 foot, because if you get longer than that, you store a lot more liquid refrigerant in there, because when you get done, this hose should be full of liquid refrigerant all the way to that tank, because that machine should be condensing it into liquid. At the very least, it's going to be a mix, and it's going to be high pressure. So the less of that we store in there, the better off we are, because we don't have to vent it. All right. Now, there's another restriction that I avoided because I hooked up to the vapor side of that tank. So I'm avoiding this restriction of that dip tube inside the tank. Now, there's a trick to that to make that even more efficient. But let's look at how much of a restriction that dip tube is. Now, the handle up here, you can see, I told you I would show you where that relief valve is. This right here, that red piece, we're looking at the back side because the hose connections are on the front side that's facing down. This is your relief valve on that tank valve, right? Here's your straw going down on the inside. And you can see the diameter of that straw is about 1/8 of an inch. Pretty small in there. Okay, it's not a real big diameter. So a lot of resistance going down through that. Versus if you look up in this hole up inside of this, this is about 5/16 of an inch. So considerably larger in diameter, less restriction. One of the other things to note too is if you look up inside this hole, you can see the passageway that goes out to that relief valve. That's designed to relieve those tanks when it's under vapor, when it has vapor on it. So if you're transporting that in your truck laying down, which a lot of us do on tank racks, that's actually going to be liquid coming out of that valve if that valve releases in the back of your truck. Okay. And I'll tell you guys, if a valve releases in the back of your truck that overpressurizes and you're driving that truck and you hear it, the first thing you do, roll your window down, get fresh air in the truck, okay, then get off the side of the road and control it. Don't try to get off the side of the road until you have your window rolled down, because you want that fresh air coming in, because any gas, especially if it's liquid coming out of there, is going to expand a bunch and it's going to deplete the oxygen inside that truck. And most of the time we really need oxygen to stay conscious, and we really want to stay conscious when we're driving in order to manage the vehicle well. It's driving unconscious generally doesn't work out so good.
I think you can get cited for that legally. Yeah.
I think you can legally, yes. I believe you're correct.
Would you mind a couple other questions? I've got them coming in here.
No, we can take a couple questions.
Okay, all right. So someone's core removal tool does, oh wow. Okay, doesn't like to pull the core out. Have we had any issues or suggestions?
Let's grab that afterwards. Have them stick around, and yes, I've got a couple of suggestions, and I will help with that afterwards.
Okay. Another question, more of a statement. Do you agree? I watched a video. They stated the purpose and benefit of valve core removal tool is to limit the amount of air and moisture entering the system.
Well, if you look at it from the standpoint of while you're working on the system, you can reach over there and turn that valve off. So say you have a system open for servicing, right? And you're going to go work off on something else. And you can turn that valve off, which limits flow through the pipe. So yes, you can limit the amount of air and moisture that enters the system. That is one benefit. That is not what I would say is a primary, what I consider a primary benefit.
Not the purpose. And then someone else asked, Jacob asked, the core depressors, can they be easily removed from most hoses?
Yes. Typically they are pressed into the hose gasket on there, that square gasket or square O-ring that's in the end. Typically they're pressed in there. Some of them are actually threaded into that, so you can adjust them up and down by twisting them. And a few of them are actually brass, where they sit all the way underneath that gasket. But grab onto them with a pair of needle nose pliers, get a good grip on it, and pull straight out, and you're going to figure out which type you have in there pretty quickly. And you should know how to pull those out, because you're going to need to change those hose gaskets or O-rings on there. I typically do mine when I was in the field about once a year. Just sit down and change all the gaskets and everything if you're still using manifolds.
And let me shoot one more question at you. Jeremy asks, is it okay to use one filter dryer on multiple recoveries?
As long as it's not causing a restriction, yes, absolutely. If the systems that you're pulling refrigerant out of are fairly clean, yeah, you can get a whole bunch of recoveries through those, because it's not there to clean that refrigerant. It's only there to keep your machine protected. Conversely, if you get a system with a whole bunch of dirt in it, you may run through 2 or 3 filter dryers. So go grab the biggest filter dryer you can find. Keep a couple spares on your truck in case you run into one of those systems. And again, depending on what size systems you work on.
Got it. I'm going to ask one more question, then we're going to get back at it. Is there ever a time when you could recover refrigerant with the tank upside down?
How about we keep going on some slides and I'll answer that question.
Cool. Okay. All right. Let's continue.
Trying to get ahead of me here, these guys are. I tell you what. Okay, anything else?
Well, someone has a basic question. Which side do you attach the hose on recovery, blue or red?
Ooh, blue or red? The answer to that would be yes. Keep this in mind. Different tanks. So some recovery tanks, liquid is blue, vapor is red. On other recovery tanks, liquid is red and vapor is blue. So you need to look on the valve, on top of the valve, it will be written liquid or vapor on there. And we're going to talk about which valve to connect that up to here. And really what you want to do is you want to connect it to the vapor valve. And we're going to talk about that a little bit more here.
Yeah. Okay. Well, I think
The vapor valve is the one without the straw on it.
right. You've got some other questions that they're coming up, but you're going to answer them. I think they're in your slides.
Okay.
Okay. Please go ahead.
Okay. Sounds good. All right, on we move. So this is another trick to really kind of avoid that straw on the tank, all right? But when we put that refrigerant into the tank, if we put the refrigerant in while the tank is sitting upright into the vapor port, because the vapor and liquid designation are there when the tank is sitting upright. As soon as I turn that tank over, they reverse. What's marked as liquid or what's marked as vapor becomes liquid, and what's marked as liquid becomes vapor because it's pulling from the opposite end of the tank. But if I have this tank sitting upright and I put liquid refrigerant into the top of it, that hose is kind of pressing in on that liquid and keeping it contained. But as soon as I push that liquid into the top of the tank up here, the vapor in there is a little squishy because it will compress. Liquid won't compress very well. Neither will the side of that hose. It's not going to compress. But vapor will compress very well. So even though it's pressurized in there, some of that refrigerant is going to flash into vapor as soon as it comes out if that tank is sitting upright. So what we do is we hook it to the vapor port and we flip the tank over and we fill the tank with liquid from the bottom up, all right, as long as we're putting liquid into that tank. Now, once we get done with liquid going into the tank, then we need to flip the tank upright, okay, and put the vapor into the top of the tank while the tank is upright. If we can put straight liquid into this tank, we keep the tank from having to reject heat. We get the tank full without having to reject all that heat to condense the refrigerant back into a liquid form. All right. Now, you asked the question. This is a question I get asked a lot. And it's very hard, guys and ladies, if there's any watching, folks, if it's very hard for me because I'm standing here talking to a computer and a microphone, and I'm not getting all the feedback from you guys in person. So it's very challenging to do this as a trainer. But right now, I get a lot of questions about, so how do we know when we're done with liquid? The secret is density, and you're sitting on a scale down here. So what you do is you watch the rate of change on the scale. How fast is it going up? And when you're putting liquid in there, it's going to go up pretty quickly at a consistent rate. And when it switches from liquid to vapor, that rate of change is going to go down. It's going to still go up, but it's going to go up a lot slower because the density is lower. So you watch the scale, and when you see that rise on the scale slow down, that's when you know that it's time to flip that tank over and put it on top. So hopefully that makes sense to you. Now, one thing you should be aware of is it's recommended to always rotate that tank in the direction of tightening the fittings, because if you rotate the tank the other way, you may inadvertently loosen up a fitting and create a small leak there. So just make sure you're rotating that tank, in a direction that you're tightening the fitting. All right. Now, another way to make things liquid going into the tank. Okay. This is called a molecular transformator. Yes, that's actually the name of it by the manufacturer, molecular transformator.
Isn't there a
And
comic
what
book
it
series
is,
that goes with that?
I think there might be.
Okay.
Suddenly it stands up and starts shooting at bad guys that were
Yeah,
standing
yeah.
on the roof behind you. Something, I don't know. I don't know. So what it is basically is it's a nice aluminum case with a big long coil of 1/4 inch OD copper tubing on the inside of it. Okay. So you got all this copper tubing, and then what you do is you hook a couple hoses to it like I have set up here. Okay. And note that there's valves on these hoses. This is an important piece of using this tool successfully. Then you drop this down in a bucket of water, whether it's just a stagnant bucket or whether you have water rotating in there. If you've got a stagnant bucket where it's just sitting, make sure it's a big bucket, because let me tell you what, that thing will put out a lot of heat and warm that water up really, really quick, which means it's cooling the refrigerant down because the refrigerant is rejecting heat, condensing it back to a liquid. So a lot of times I would just use a smaller bucket. Now, since I learned the tank flipping trick and some other tricks, I actually don't use this anymore. It sits in my garage, and now I get to use it for teaching and training and showing people how to use it properly.
I saw a cutaway of the coil that's in there. It's actually
Yeah.
rifled on the inside to increase heat transfer, so it isn't just straight smooth copper.
Oh, okay. So they actually got the rifled tubing like is used inside of a standard evaporator coil or
Yeah.
a condenser coil.
Yep.
Okay. Yeah, that's really common in those actual units to have rifled tubing. I didn't realize it was rifled in this. That's good to know. Thanks. So drop that down in a bucket of water. I just leave this set up all like this all the time. The hoses stay on there. They're coupled together to keep dirt out of them, whatever else. But like I said, you got to have the valves on there. So this is how you configure this, right? We're going in through the manifold. Then we come out through the molecular transformator, right? Because we're transforming the molecules. Go Transformers. Oh, wait a minute. No, that was G.I. Joe. No, sorry. No, not Go Joe. There you go. We drop this in a bucket of water. Run that over here. You can still flip the tank, fill it from the bottom up. The challenge with this is because it's on the discharge side, because it's sitting in a bucket of water, because it's configured like this, you're going to have 2 hoses and a coil of copper full of liquid when you're done, right? And depending on the machine you use, even though there's a purge cycle on those recovery machines, that purge cycle cleans out the condenser coil that is in the recovery machine. It does not do anything for this discharge hose, right? It can't magically pull refrigerant out of the discharge hose and then push it back out the discharge hose into the tank. It doesn't work that way. So when you're ready, done with recovery in the system, you need to valve off your 2 connections right here and right here, trapping all that liquid in this. Flip your tank and reconfigure your machine because you need to recover all the liquid that is sitting inside this molecular transformator in those hoses, because there's a pretty substantial amount of liquid stored in there. So you need to reconfigure that and recover that down. Again, it's a feature that is necessary to be used on that type of a setup. So just so you know about it. Now, let's look at another setup, and this is what I use now if I'm going to do a recovery, and it works really, really well. So it starts with this piece. Now, Appian made these Y pieces. I don't know, Bill, when did they come out with those? Last year?
I think they introduced them at the HR Expo this year and started shipping them maybe 2 months ago.
Oh wow, has that been that short a
Yeah,
time?
yeah. I think you've known about it for longer, Eric, if truth be
Yeah, a
told.
little bit ago, but yeah. But this is really, I like this setup. It makes it really easy. And here is how I configure it. Okay. So yes, that is correct. This says 3/8 and 3/8 on here. And they did that because they were already making these red and blue hoses with 3/8 connectors on one end and 1/4 inch on the other end. So this is how I load out a setup ready to go for recovery. I've got my 2 hoses connected to that Y. I have my filter dryer already on here, ready to go, 2 3/8 hoses, and I've got a hose park back here on those two so that it all stays clean and dust free in my truck. I'm not getting a bunch of dirt and junk in it. Okay. And that looks like this when it's all connected up. And I use a probe style gauge over here on my core tool. Whoops, hitting the button again too soon. Sensitive touchpad on this computer. Use core tools over here, put this on the side of the core tool. That monitors my system pressure, where it's at, so that I make sure that the system is down to the required level. Through my filter dryer, through a short 3/8 hose, rather than using a 1/4 inch hose between the filter dryer and the recovery machine, and then 3/8 hose out, and of course running the tank upside down. Now, when I talked about using this tank flipping, I was down in Florida earlier this year, I believe, and a guy from South Louisiana piped up and he says, I've been using that tank flipping for a year or so now. And one of his distributor down there told him about it, and he's using this on rooftop units in South Louisiana, and he's not having to go on and use ice or water or anything else to keep his tanks cool like we typically did a lot of times in those situations. So South Louisiana summertime, he's using tank flipping, he's using low restriction, and he's filling that tank up without having to cool it. I really couldn't get a much better vote for using the tank flipping procedure than that, because I think maybe South Florida might be the only place in the United States that's really a much worse, well, or maybe Death Valley, but they don't have humidity there, so we don't care about them, because I'm in the Midwest and we got a lot of humidity around here. It's a dry
So when
Death Valley.
When that person called you flipping crazy, there was actually a compliment?
Yeah, exactly.
Okay, good.
Now, okay, so flipping the tank. Now, push-pull. Okay, so this is your push-pull configuration. So we set up a hose and run a hose directly to that tank. You can do push-pull with the tank inverted or right side up. And I was actually thinking about this and I configured it inverted, but it may actually work a little bit better. I've not ever tested it. It may work a little bit better right side up, because when you're bringing the liquid in, liquid has greater density, and you actually really would like to have that larger port to pull the vapor off the top. So I would probably opt for setting the tanks upright, and especially if you're using larger tanks, your 100, 120 pound or ton tanks, you're not going to go flipping those over. Tank flipping only works if you're dealing with the 30 and 50 pound nominal tanks. Okay, so then we take the other port where we get the vapor off, we pull the vapor into the machine, pressurize that vapor, and we push the vapor back into the system. So we're pushing the liquid out of the system, right, and into the tank. Now, one thing to note about the system here is this only takes liquid out. So when we're doing push-pull, we only pull liquid out. When we're done with liquid, we have to switch over to a direct recovery and pull all the vapor out. So we definitely want the tank upright then, and we're going to put the vapor on and bring the vapor in here. Okay. Again, always keep it on a scale. Now, if you're working with large systems that require multiple tanks, this is a neat little setup right here. Grab you an extra core tool, screw it on the end of the hose, and hook it on directly here. This allows you, when you're switching tanks, so that you don't have to repurge all your hoses, you just turn your valve off right here, and you use this handy dandy little side port that's in between the tank valve and the core tool valve as your bleeder. So you can bleed that, you can bleed the pressure off before you go to disconnect it, and you can also use that as a purge feature. So what you do is you turn the tank valve on first, and you depress that Schrader core in there briefly, and it will purge all that air, any air that's sitting in there, back up and out that Schrader core. And then you go ahead and open both valves up and continue to put the refrigerant back into the next tank. So that is, unless your tank is under a vacuum, in which case you're going to open your core tool valve and purge with the refrigerant coming from the hose. So it depends on how your tank is set up. If it's
That's
already under
really-
a positive pressure, you can purge with the tank.
That's really cool.
Okay, so these little core tools are multi-function tools. You can use them for a lot of stuff. One of my favorite uses is where I have a manual control valve, like a king valve or a queen valve or a service valve, where I'm working with a wrench on that. Okay, now anybody that's worked with one of those knows that the packing nuts leak on them, right? Every one of those packing nuts leaks. And we very rarely have the right wrench handy to tighten them down to make them stop leaking. So if I'm doing especially vacuum on those, I actually use my core tools. Even though there's no cores to remove, I'll put that valve on there as my control valve. I set that stem at the halfway point, okay? And then I leave it alone so I don't have to move it, because they leak worse whenever you mess with them. And then I'll put the cap back on top of that stem. Okay, then I can do all my service work, get everything done. Okay, then I close that valve when I'm finished, and then all I do is I pull that cap off, I back seat my stem, everything's closed, I pull my core tool valve off. Right, I don't have a core to put back in, but I use it as a control valve. It is a control valve. It's not just for removing cores anymore. Maybe that should be a new slogan for somebody. Not just for removing cores anymore. So now a little bit of maintenance, okay? Different machines have different maintenance requirements. Some of them want you to put a little bit of oil in them once in a while. I've seen a lot of requirements. So there's not one maintenance requirement for them. Keep them clean, right? I don't like to have caps on these all the time. A lot of places want to stick caps on there, but I've seen these units when they have a little bit of refrigerant left in them, okay, and you put the caps on there, you end up with high pressure building up inside these units while it's sitting in the back of the truck, because of course it gets really hot in there. So you can actually build up quite a bit of pressure if you have a little bit of refrigerant sitting in that, because you got a really small space inside of there. So I actually like to have no caps or loose caps on here at best if you're worried about keeping dirt out of it. Maybe the caps without gaskets in them or something like that, where they can actually breathe a little bit and allow that pressure to relieve. Okay. So, and I was going to show you guys a hose purging technique, and I don't have it on the computer here. So we'll show that in the live portion afterwards. So everybody that's still here, thank you very much for attending. And again, Bill and Eric and the guys over at TruTech, thank you very much for hosting this tonight. It's a lot of fun. I really like talking about things like this and helping the trade out, hopefully. So anything else you want to cover right now, Bill?
I'm going to go back through a couple questions here, just kind of do a
Sure.
little cleanup here. When you were showing the pressure, the gauge hooked up on the suction line, that was a pressure gauge, not a micron gauge.
Yes, correct.
Yeah.
This is a pressure gauge because you're dealing with positive pressure where you're pulling down. Now, this should be a compound gauge where it will measure below atmospheric pressure, and it will go into negative inches of mercury, because negative inches of mercury is what the EPA, when we have to pull below atmospheric pressure, negative inches of mercury is how the EPA tells us the levels are inside of that system.
Okay. Someone asked about Texas weather flipping the tank.
Should work just fine down there too.
Yeah.
I mean,
gravity
you know,
and everything, right? Yeah.
Gravity, I don't think gravity's quit working in Texas.
Okay,
I hope
okay,
not.
good. A little worried. when recovering different refrigerants with the same recovery machine, is there a danger of cross-contamination of different oils inside the machine, thereby contaminating your recovered refrigerant?
No, no. Purge your machine out. Make sure that it's empty when you're done. You don't want to store refrigerant in your machine. And every time you start, you need to purge all your hoses all the way through your machine, all the way up to the tank. Okay. And the way you do that, I'll describe it here real quick for you. Okay. The way you do that is you turn this outlet valve on the machine to the off position. Right. You turn on the two core tools over here, pressurize all these hoses, turn your inlet valve on. The hose should be disconnected from the tank at this point. Gently open, start opening your outlet valve on the machine and allow just a trickle of refrigerant to come out of there. Let it purge for a little while, because you've got to purge all these hoses or the manifold or whatever you have, the machine, everything else. You got to purge all that out of there, right? And you got to get all that to the end of the hose. Purge it all out of there, right? Push it all out. Then as it's gently purging, again, don't do a strong like whoosh, purge out of it. Gently purging, then you can reach over and screw that on the tank as it's gently purging. And that's going to be your best purge, because you're attaching it to the tank while it's gently coming out, so it's displacing all the oxygen out of there, and it's going to keep everything as clean as possible. That's the easiest and safest method that I have found to purge. The person that taught me to fill everything up with high pressure and then crack the hose on the end. And first couple times of burning my hands, I decided maybe there was a better method to doing that. So yeah, kind of gave that one up. So hopefully I answered that question a little bit more there.
Yeah. So are there different methods when recovering refrigerant from heat pumps due to the reversing valve?
Not really, no. On heat pumps, you just need to access whatever you can wherever the refrigerant is. Because a reversing valve shift happens with pressure. That voltage, the solenoid on there reverses pressure, and the refrigerant pressure actually pushes that valve back and forth.
Okay. Is there any maintenance required for a recovery tank, or to tune it up, keep it operating well?
For a recovery tank, it needs to be sent back in every 5 years and have a hydrostatic test done on it and a visual inspection. All right. And those certification dates are on your tank. If that certification date, and they put the date on there when it was last checked, if that is beyond 5 years, then legally you're not allowed to transport that down the road in a vehicle. Some of the other things you need to watch out for on recovery tanks, you want to watch out for dents, major rust happening, anything that could potentially physically compromise that tank while it's under pressure and cause it to rupture. You want to take it down and pull a vacuum on it. It's best to pull a vacuum on a tank before you connect it up to the system, as long as it's empty. Now, if it's under positive pressure and has a known refrigerant in it, then you don't want to pull it down in a vacuum, obviously. But you need to pull that into a deep vacuum with a vacuum pump. And we're talking about a 500 micron vacuum here. Periodically, maybe you want to check them for leaks too, because they do leak around the valve a lot.
And when you say get them certified, is that back at the manufacturer, or are there shops that are set up around that do that?
Send it back in through your distributor. Typically, your local distributor is going to be able to take that back and send it back to a reclaimer, and that reclaimer should either work with a certification agency, or they should have their own in-house ability to do those certifications.
Okay. And the question was mistaken here. It was, he meant the recovery machine, typical maintenance or service, keep it in tune.
Gotcha. That is going to be machine dependent and manufacturer dependent. Some of them want you to run a little bit of refrigerant oil in there and actually suck it up in the machine. Sometimes to keep everything, a little bit lubricated in there. basically the best thing that you can do is keep that inlet screen in place and clean, and keep the filter dryer on it all the time. If it's got fans in there, of course, you want to keep those fans clean, because just like the blades, the fan blades that we deal with on equipment, if you get dirt on those fan blades, it's not going to move as much air through it. And those fans are in there not necessarily to keep the machine cool, but each machine has a condenser coil in it to help condense that liquid refrigerant, condense the refrigerant back to liquid after it comes out of the compressor. And that fan is there to move the air through that condenser coil and help to condense that refrigerant back as it's leaving the compressor and going into the tank.
Got it. Someone's had some cores break off. We're trying to remove them. Anyone else had the issue, or any tips you could give people?
Ooh, cores broken off. That's a challenge. And it depends on where they break off at. If it's just the tip of them breaking off, I want to say JB or C&D Valve, I think, makes a core extractor tool and a rethreading tool that you can buy, and they work with, I don't know how many core tools they work with, but you can actually go in there, and it's kind of like an easy out. If you've ever used an easy out, where you jam it in and it's got teeth in it, and you turn it to the left and it grabs and loosens.
Got it.
I can't say I've ever had to use one on that application though, so I don't know how well they work.
Someone's looking for a copy of the slides with the recovery tank upside down. I think they thought that was a pretty neat illustration.
Okay.
Yeah.
We'll see if we can get
Okay.
maybe we'll get all the slides out to everybody here.
Okay. And
put 'em in
someone
a
mentions
PDF.
that C&D does have that tool, that extractor tool you mentioned.
Okay, I thought so. I think I've got one somewhere around here, but I would have to go digging to find it, honestly.
Yeah. Is there a core removal tool for larger cores?
For 5/16, yes. And by larger cores, I'm assuming that they're referencing the CoreMax cores that are used on a lot of systems today. And those can be a real bugger. But yes, there is a tool out there. Again, I think JB makes that, and I think you can get it from CoreMax as well. But I can tell you from when I looked into them, they are not inexpensive.
Yeah. Okay.
I don't know. Do you guys handle that?
I don't think so. I'm going to check into it now. I'm making notes here like crazy, man. Someone asked, should they keep nitrogen in their hoses?
No, I wouldn't worry about it.
Yeah.
You don't, as long as you keep your hoses parked. And what happens is when you vent those out and you bring it back down to atmospheric pressure and then you park it, it's full of refrigerant. It's got a little bit of vapor refrigerant in there. So that should be sufficient inside that hose. Just because you vent it down to atmospheric pressure doesn't mean that it immediately fills up with air. It's going to have a little bit of air in there. It may have a little bit of mix, but it's probably going to be mostly refrigerant in there at that point, because all you've done is equalize the pressures. You haven't actually exchanged anything, because you have to put a force through there to actually exchange everything.
Can you repeat the purging method?
Repeat the purging method. Okay.
I think that goes back a while. That's like about 6 minutes ago.
Yeah. So we're talking, I can repeat the purging method. How about I set up a tank here, and I just happen to have a recovery machine sitting in front of me, and I'm going to turn on a video here. I'm going to turn this slide deck off, and we are going to switch screens. I'm going to stop sharing. Okay. And what I need to do here.
That's your mugshot.
That's my mugshot, and it is ugly. I'm telling you what.
Not half bad.
Not half bad. Okay, let's turn on video. That was not the video that I had expected to see. Ah, there we go. Pin the video. Hey, look at that. Can everybody kind of see that more or less?
Yeah. See, yeah.
Hey,
Oh,
you can
it
see
just
my
went back
hands.
again.
Just went back again.
There, now it's back.
Okay. Okay, so purging setup. We'll use a hose here. Let's adjust that, make that camera adjusted just a little bit so you guys can kind of see this a little bit better. Can everybody see that all right?
Yep.
I should have this video pinned. So, oh boy, here we go with the rain starting up. Okay, so what we're going to do, and what I'm going to do, outlet hose, discharge side of the recovery machine, we're going to leave this hose loose for right now. Now what I'm going to do is I'm just going to put up a little bit of nitrogen pressure on this just to kind of simulate refrigerant coming through it. So we're going to close the outlet valve. I'm going to give pressure to this. Okay, there we're coming up. So I've got about 100 PSI coming into this. Now I'm going to crack the outlet valve. I'm going to just open that until I start hearing. You know what? I got a problem. My problem is I got a bum hose over here. Let me switch my hose out. That hose, I know what's wrong with that hose. It's old. And
It looks it. They actually do have service lives. People keep that in mind.
Yeah. Well, what happened in that one is the gasket is really torn up in it. Yeah, hoses have service life. When they start showing, if you start seeing cracking, I don't know if I have one around here. I happen to have a bunch of really old stuff that I kind of inherited. I don't know where. There it is. I knew I had one. I don't know if the resolution on this camera will show this really well or not. But you can kind of see the cracking starting to happen in that outer jacket on that. And if you do this and you see cracking or checking in that outer jacket, it's time to get rid of that hose. Take it out of service. All right. This stuff is not worth risking life and limb over. It just isn't worth it. But yeah, that other one, the gasket is so messed up on it that anytime I tighten it down enough to where it doesn't leak, it compresses the gasket really hard. And it compresses the gasket into the core depressor so much that it won't allow any flow through it. So now I've got some pressure in here. So I'm going to open this gently. And you can probably hear that, right, coming out of there. And I'm just going to let it purge. I may even bump it up a little bit, but then when it comes down time to connect that, I've got a gentle flow coming out here. It's not blowing refrigerant everywhere. And then I'm going to have these valves are going to be closed, right? While that's coming out, I'm making my tank valve connection up here. Make it so you can see that a little bit better. And I made my tank valve connection. Now I come over here, open my valves up, and start my machine. Okay. Tank would be sitting on a scale, of course, and we get everything up and running. Hopefully that kind of makes sense to everybody. I know sometimes it's easier to see it this way in a visual representation.
Right. I mean, those are good slides and everything, Eric, but come on.
There's nothing quite like seeing it live in person to be able to understand what's going on, right?
And you do a lot of in-person training, so I guess this coronavirus got to be killing you, man, because you like getting in front of people. I know that.
I do really like getting in front of people, and yeah, it was hard, but I'm learning a new life now, right? You know, sometimes we get to learn new things, and I am kind of enjoying not traveling quite as much. That's for sure. So what else have we got?
Is it ever a good idea to recover directly from the liquid side to the recovery tank without a recovery machine in series?
Well, that's kind of what you would be doing with a push-pull technique, right? We're taking it liquid to the tank and then we're pulling vapor off the tank. Yeah, you can do it. You still need to weigh your tank because, again, if you overfill that tank, you're going to be in trouble. You're going to have, you're going to have some issues.
Got it. Someone asked for steps on vacuuming a tank.
Vacuuming a tank, you want to have a vacuum pump, hook it up to one side. I would typically probably hook it to the vapor side and put my, let's see, on this one. Yeah, red is liquid on this one. Then I would hook my vacuum gauge up to the liquid side, right? And I would pull until I get that reading over here on my liquid side on my vacuum gauge, whatever I'm shooting for, the 400 or 500 microns.
Another question here, I guess as long as you got time, people keep coming up with the questions. Jeremy asked roughly how, you got time? You good?
I got the time.
Okay. All right. You're just sitting there sweating anyway. So we just want to see how long you can stand this humidity.
The rain is coming down now, so I think it's actually cooling it in here a little bit.
Good for you. Jeremy asked, roughly how long does it take to purge the entire recovery machine?
Okay, I'm back now. I muted myself there to get a drink real quick. It depends on the pressure coming through it. I normally go, and depends on how far you open stuff up and the flow coming through it. I normally 15, 20 seconds at a pretty decent flow rate just to make sure that I've got everything, all the way through the hoses and all the way out here to the end.
Okay. Why should we use recovery instead of pumping down the condenser?
Well, you might not want to. On certain condensers, you can't pump them down. If you're talking about a microchannel coil, you cannot pump down microchannel systems because the inside of the coil will not hold the volume of refrigerant, and you'll either hit the high pressure switch or worst case scenario, you end up blowing up the coil. And where did it go? I used to have, I do have. You just got to wander around my shop long enough and you find all kinds of neat stuff. And thankfully, microphone, I can wander around a ways. So microchannel coil, okay? Lots of little tiny passages. There's like 30 some passages all the way across this width. Inside of that, there's no real volume in there, so the pressure goes up really fast when it becomes liquid full. There's no cushion volume to them. So on those, you don't want to pump them down at all because there's very real danger of damage and or injury with those. So in that case, yeah, you want to recover it. However, if you can pump it down and not have to get a recovery machine and a tank out, I would absolutely do that because you are actually keeping the refrigerant potentially cleaner because the inside of these recovery tanks is not perfectly clean. I've got one around here and I've got 2 tanks in the shop here right now that are both brand new. And both, one of them you can actually shake around and you can hear weld slag. I don't know if it's this one or not. Yep. And you guys probably can't hear that, but I can actually hear it. Anytime I roll that tank over, it rattles. There's something rattling around in there. And even when they go in for inspection, these tanks don't get cleaned out, and pulling a vacuum on them does not pull solids out of it. So if you get oil or anything else sitting down in this tank, right, it stays in there. It doesn't actually come back out. So I don't like to reuse refrigerant out of recovery tanks unless I know, what that recovery tank is, and I've had control of it its whole life. It's stuck with me since it was brand new or whatever. So pumping down can be very preferable sometimes. I know that was long, but hopefully that was a kind of a good answer there for them.
That was a good answer. Good answer. Here's from Yannick Kale. Pulling a vacuum without cores in the service valve will save you a tremendous amount of time and save your pump from running longer than it should. Bigger hoses are a game changer. Okay, that's more a statement. Let's see.
I'm 100% in agreement with that, by the way.
Yeah, cool. What are your thoughts? What are your thoughts on using your Schrader core remover to remove the Schraders on the service valves when pulling a vacuum on a system?
Yep, absolutely.
That's one of those other purposes, huh?
Yeah, that's one of the other purposes. They are a multi-purpose tool. One of the greatest things I ever found was, and Appion was the first one that hit the market with their vacuum rated core tools, and they're still my favorite today. I've tried a lot of other ones. These just work. They're comfortable. Yeah. And that kind of brings us back to what we talked about earlier, or what we were asked earlier. Let me see if I can get this to focus here, about cores, right? They were asking about, whoops, that's not what I wanted. I want the other button. There's the other button. That should help a little bit. They were asking about having problems with pulling cores out, right? So there's a couple challenges with core tools. One is if you over tighten them, you actually can compress this little O-ring down in here to the point where it restricts enough that it will actually grab that core as you're sliding the stem back through it, right? It'll strip the core off that stem. So tighten them down as snug as you think you need to, and then back that off about a quarter of a turn, and I'll bet that will solve your problem. Now, the other possibility is that you have one of the newer Appion core tools. Now, they changed the design of this last year, and the tip is different. You can see the early design versus the late design there, okay? And the second design, let me go back to the first design. The first design has a little teeny tiny O-ring down inside that black tip, and that O-ring actually grips out on the end of a core. It grips out here, and it holds the core like so, right? So it's holding it in by this little tip out here on the depressor. The second design slides over and grips like a pair of fingers on both of the flats right out here. Okay, so these are adjustable. And to adjust these, if you want more tension, you take a pair of pliers and you squeeze on both sides, and you give it a little bit more tension, or you take a screwdriver in here and you rock it back and forth gently to spread it back apart a little bit if you can't get it on. These should be difficult to push on. I mean, you should push a little bit, and you should feel positive engagement when that slides in. You want to feel that grip on there. And then once it's on there, you can hold it up by the core tool or by the core itself, right? I'm holding that just by the core, and it's staying on there, but it's a good grip on. That's my recommendations. Now, if loosening it doesn't fix it, and you've got the old style like this, that O-ring may be worn out on the inside, and you may need to actually replace this whole stem, because to try to replace that O-ring is pretty doggone difficult, because you got to drive a little tiny roll pin out. Then you actually have to find the O-ring, which is very, very small. And then you have to go in and, daggone it. Why is this thing going down on me? It's going the wrong way. There we go. Let's brighten it up a little bit. Okay. So hopefully that answered the questions about the core removal tools, I'm thinking.
Yeah, that sounds good. When a recovery machine is not on site, but a vacuum pump is, can refrigerant be removed from a system? what's the hookup scenario?
No, I would not recommend using a vacuum pump for a recovery machine. You can start the flow into a tank, but they are not designed to move that volume or that type of a gas. They're not designed for that, and you're going to end up damaging your vacuum pump if you try to use it as a recovery machine.
Okay.
The first thing you'll do is probably blow all the oil out of it.
Someone asked, is it true you can't pump down a microchannel condenser coil?
Yes. Yes, you do not want to pump down a microchannel condenser coil. Not a good idea.
Okay. Do you know of any stems that are available without buying the whole tool?
That are
For the core
any
removal
stems
tool?
that are what?
For the core removal tool that are just sold separately. I'm looking here on our site and I don't see them.
I don't know if anybody sells just the stems themselves, to be honest with you.
Yeah.
You know, I've used core tools. I mean, Appion, I've got a bunch of different core tools. Appion has iterated, I want to say, through three different generations that I know of two different generations of this design, and then this is the essentially the third generation right here, because they started out with a brass stem like a lot of them used to be made, and then they switched to a stainless stem, and I think there were a couple other minor changes in there somewhere, but I'm not sure on that. I don't remember all the history on it. But I still have one of the original brass stem ones, and I don't use it much, but even it and even my early stainless ones are still not worn out. I haven't seen a lot of those getting worn out unless you're just using them a ton.
Okay. Any opinion on the EcoTools core removal tool?
I have one. I'm gonna be honest. I've tried it one time. It feels weird to me. Just the way the knurling and everything is on it. It works, but I really haven't taken and fully tested it to see what all it will do yet. So I haven't super formed an opinion on that one.
Okay. Will there be a visual indication of liquid refrigerant when purging the recovery machine? Will the refrigerant be exiting the machine in a liquid or vapor state?
Well, if you're purging real slow, like what I just talked about, chances are no, because you're going to, because you're flashing it right here at that valve. By the time it exits that hose, it's all going to be vapor. Now, if you open this valve up 100% and you let everything else out, you know, and you just let it come out of there, yeah, you'll see that liquid when it starts coming out. Let me show you guys another trick on this G5 too that I really like, which is it's a safety piece, because right now I've got this hose full of high pressure, you know, refrigerant. You know, I'm using nitrogen here tonight. But if you close this down, close your inlet valve now, this would be the not normally leak off anything when I disconnect that. But now that I have that clear, right, and I haven't tried this on other machines because I've used this machine for a lot of years. This was my personal machine that I bought, I don't even remember how long ago, but it's been a while. Probably pushing 11 or 12 years now, maybe. I got to stop thinking about that. It's depressing. But because this is full of high pressure refrigerant, I don't like to go up here with my hands and take it off, because I'm risking burning my hands off, you know, burning my fingers when I'm doing that, even if I've got gloves on. So what you do is close the inlet valve, leave the outlet valve open, disconnect your inlet side. Everything internally should hold back. Then you slowly crack the inlet open, and it back bleeds your hose and everything else back out of the inlet port. Make sure you have your tank valve closed when you do that. Releases all of that, and then I can come up here. Well, that one held on for some reason. Gonna have to figure out why that did. Normally it back bleeds everything back out of here, and you end up with a, oh, I know why. Because I took this valve too far. In order to do that, you stop it at the 45 position. So when you turn this valve to a 45, it opens up a passageway between the high and the low for equalized starting purposes. So you have to leave it at that halfway position. I went too far on it, and I went past where it was bleeding out. But then when you go to disconnect this hose, you don't have any high pressure in that hose, and you're not risking blowing liquid refrigerant out onto your hands. I don't know if any of the other brands of machines have that. It would be something to maybe try and experiment with.
Got it. Hey, I think we're probably at like a time limit, just a natural time limit out here, running up on 2 hours.
Yeah, we're done. We've come down to 145 people, so I mean they're starting to tail off.
That was 193 at the peak. So,
all right.
I don't want to wear you out either, man. I really want to thank you, and so many thanks have been coming in just over the ever since we started to stop. So it's really great having you here. I think we got to get you back again if you'll do it again. I think it's a really great way of sharing the knowledge that you have and helping the industry out.
Yeah, I think it'd be a lot of fun to come back out and do this again sometime. I really enjoy training and sharing what knowledge I have. Sometimes it's not much, but I'll share what little I have.
All right, great. Well, I want to thank everyone for sticking in here for the full period of time, and for your attention and your attentiveness and your questions for Eric. Obviously, it's an area that people want to learn more about, want to gain that knowledge. I think we had a broad spectrum from people just starting out to really seasoned veterans listening in on the call. So you attracted a great audience, Eric. Thank you.
Well, you're very welcome. I'm like I said, more than happy to do it here. So we'll, there we go. Now you can see me standing out here in the heat, sweating.
And I'm going to do one quick thing and just let people know that I think hopefully you can see this.
Yep, I see your screen there.
Yeah. So we want to remind people that you can enter for a monthly giveaway just by going to our website. Just click on the little box there. It'll take you to a Google form. We do carry most, if not all, the products that Eric mentioned tonight on our vacuum recovery products page, broken down by category, including recovery tanks, hoses, everything you need for vacuum recovery. And I'm probably getting a message here. Move closer to the mic. Okay. A lot of people are telling me that. Move closer to the mic. And this is Eric's email address. I hope that's okay. I shared it, Eric. You can always filter everybody out from there. And again, just can't, also we do run a blog. If you look on the top of our website now, we've got a few different posts on our blog going there. Another way to learn, another way to interact with TruTech and the industry. So I'm just going to wrap it up here and thank everyone for attending. And thank you so much, Eric, for presenting.
Bill, I appreciate it. Thank you very much for having me tonight. And thanks everyone for attending. It's been a lot of fun this evening. Great. Hopefully maybe I'll get some air conditioning in here in my shop at some point so I don't have to stand out here and sweat. But
do you know anyone that does air conditioning? Do you know anyone?
I don't. I'm going to have to think about that. I don't know if I know anyone or not.
You're doing a lot of thinking tonight. All right. Sounds good, man. All right. Thanks again.
Thanks, everybody.
Take care.
Have a great evening.
Yep. Bye-bye.